And my name is Calvin Lin. I'm a professor in the computer science department, and I'm also the director of our Turing Scholars Honors Program.
Thank you for being here today, Calvin. We really appreciate your time. So we have a number of topics we wanted to cover for the students that are attending the Summer Academy. And our first question is just about the department itself. What's it like, and what is the Department of Computer Science?
So I guess the first thing I would say is that UT's computer science department is one of the top 10 CS departments in the country, which means we do excellent research. But one thing that this ranking does not reflect is that from an undergraduate's perspective, I think our ranking, if there were one, would be much higher. And that's because we've done a lot of things that I think really make it a much more welcoming community and environment than a lot of other schools. So for example, you may think of UT as this huge school with 50,000 students, and of course that's true. But within, compared to other computer science departments, our CS class sizes are actually quite small. So for example, you think of small private schools like, I don't know, the Ivy Leagues and Stanford as having being very small schools, but they have huge class sizes. So the average Stanford CS class size last year was 125. I just read an article from folks students at Columbia who were complaining that they have hundreds of students in all their classes. They were told when they became juniors and seniors, they would have smaller classes, and they're finding now that no, their junior and senior upper division classes are just as large. And that's because a lot of these other places allow any students to take computer science classes. We have a slightly different system here at UT. And that's not to mention other public schools where, for example, at Berkeley, their data structures course has 1,500 students. And I only mention that one because I teach the corresponding course here for our honors program, which, last semester had 48 students.
As an incoming freshman, would the classes be large and then they would migrate to smaller classes as you move up?
Yes, we do have a few large classes, and certainly compared to high school classes, our classes are large. So for example, our intro programming class, I think, has somewhere between 125 and 150 students. But after that, the class sizes would get smaller. And certainly we're not talking about the hundreds like these other schools.
A question about when you start off as a freshman in computer science, you, I assume, take some general classes and then you start to specialize as you move up. And can you talk about some of those specializations?
Yes. In fact, before I get to there, let me say a couple of things. One, there are some schools where you're not really allowed to take too much computer science your first year. They sort of have this general program. We don't have that philosophy here at UT. So based on your capabilities, you can jump in as quickly as you want. The other thing I wanted to point out is that our program is structured with a very small core. So there are 6 required courses of all computer science majors, only 5 if you've taken and done well on the TXCS test. And then you take whatever courses you want. If you're interested in machine learning, you can take those courses. If you're interested in graphics or systems or theory or whatever, biology, computational biology, whatever it is you want to do, take those courses. And since to answer your question, Mary Esther, it's not an easy answer because we actually have a huge variety of course offerings for our undergrads. And in fact, when I came here many years ago, I was kind of astounded when I saw the course catalog and saw how much variety there was, right? But I've really come to appreciate that. I think it's good for our faculty who get to teach interesting courses that they're passionate about. And it's really good for the students because they get to have all sorts of in-depth courses in many different areas.
That might lead into one of my next questions is, what do you see the future of computer science?
That's a great question. So, I like to think about computer science kind of like science fiction, right? We have this phenomenal power at our fingertips, and it has been changing the world for decades now, and there's really no sign of it slowing down. If you look at computer science as a field, it has become increasingly outward looking, right? We're seeing the influence of technology, and in particular computing technology, on everything from politics, religion, art, science, government, everything you can think of, right? And so it's the reach of computer science is it's just sort of up to your creativity, right? And that's why when I mentioned these other schools having huge class sizes, you have liberal arts students and students of all majors trying to take computer science courses because they see that same trend, right? And so anyway, so yeah, I think it's hard to, as I say, predictions about the future. Predictions are very hard, particularly about the future. But I don't see the influence of computer science waning for the foreseeable future, right? I mean, put it this way: think of the world's problems, and certainly we have many, right? It's going to take all sorts of political will and other things to fix these things, but I actually think technology can play a huge role in all of these things, right? So, if you want to think big, whether that's making money and getting rich or solving the world's problems, I think you want to think about how you can leverage technology.
I think that a lot of the students want to know, what is computer science? I'm not sure what it is. I know that I have a programming class at school, maybe, hopefully, but what is computer science?
First of all, computer science is not programming, but programming is oftentimes a big part of computer science, right? So what I would say very succinctly is that computer science is the study of computers and computing. And we can compute without computers, right? So some of the oldest computers were actually not digital, right? And of course, I mentioned the uses of computers, right? And this is what you had just mentioned a minute ago, right? I mean, right now, I think most of our students, their lives are completely dependent on computers, and maybe even in ways that they don't even think about, right? Like you don't think of your phone as a computer, but of course it's a computer. And I guess the way I would kind of put it is that, the assembly line was this big deal, right? Because it made us much more productive, right? And so we got mass production and all that kind of stuff. But what programming lets you do is it lets you do this, what you might call mass customization, right? It's now, instead of producing, a million sneakers or basketball shoes, you can, we've developed the technology to the point where I can say, no, I want a size 10.5 and I want purple and yellow and I want my initials on the back or something. And it comes off the assembly line just as well as all the, red and black sneakers that they used to sell in the past, right? And that's the power of programming. It's taking, or another way to look at this is, your parents had either phones that were flip phones or they weren't even portable, and they did one thing: you could dial a number, right? Whereas the difference between that and a smartphone, or what you just call phones now, is that they're programmable, so they can be basically whatever they want to be, right? So that's sort of the power of programming in computer science, is it just sort of opens up the world.
Can you tell us, Calvin, a little bit about your background and how you got to be in the position that you're in at the University of Texas?
So I grew up in the Bay Area in California, back when there were still orchards in the Silicon Valley. I went to college. I sophomore year, 3 days before sophomore year, I realized that I had to choose my courses. And it also suddenly occurred to me that, whatever I chose was going to determine my major and maybe even my life, right? And so I knew I wanted to do something technical. I wasn't sure if it was math or physics or engineering, but so I looked through the different courses offered for each of the majors, and I realized I had no idea what I was doing. And so in other words, I looked under computer science and I saw things like compilers and automata theory. And I thought, well, I have no idea what these are, so that doesn't help me. And I looked under physics and it had all these things, So anyways, so, I was kind of puzzled. And then I thought, I know computer science is not programming, but the most fun I had last semester was in my programming course. So I'm going to give it a shot and go for computer science. And so, it was a very ill-formed decision, but it sort of was the best decision I ever made, because the more I looked into computer science, the more I was like, wow, this is really cool. And then I went to graduate school in Seattle, University of Washington, and the same thing happened, right? I thought I had an understanding of what computer science was, but the more I was exposed to new ideas and courses and other things and research, I was like, wow, this is really cool, right? And then at some point during my career, and why did I go to graduate school? I went to graduate school because even though I had had a job at Microsoft the summer before, and I loved it, I loved making money, I loved programming, I couldn't see myself just programming for 30 or 40 years. And I thought, well, if I go to Ph.D., I can do research, I can maybe have more say as to what I do, and maybe it'll be more interesting work, right? And so I went to University of Washington, and famously, I turned down, my boss at Microsoft offered me a Lamborghini. He said, well, if you come back, I'll buy you a Lamborghini. And I said, no, that's all right. I'm going to go to graduate school. So at any rate, or maybe he was going to give me his Lamborghini because he'd driven me around in his Lamborghini. So at any rate, I went to graduate school, and partway through it, I just realized, wow, I think I want to be a professor, because it never really occurred to me until then. And I guess the rest is history. I've now been here since 1996, and I love my job.
I'm going to share a little bit about why I went into computer science too, because we haven't talked about that with our participants. And so when I was growing up, my brother decided to go into electrical engineering, and I wanted to do anything my brother did. He went off to UT, and he called me up one day and he said, Mary Esther, I don't think this is for you. I was crushed, just crushed. And he said, but there's this other thing called computer science, and I think you would like that. And so I said, okay. And so that's what I did. I just kind of blindly went into it, but it turned out I just absolutely loved it. Now, I also loved being a programmer. That was the best thing in the whole world to me, was getting behind the computer, telling it what to do, and it did it. So there are a lot of different paths that you can all choose. That's what we want to reinforce. You can mold your own path, and then you can take that, and it can change over the years. You don't have to do the same thing the whole time. So remember that.
Right. There's this vision that if you're a computer scientist, you're a geek who sits in a cube, and that's, like you don't actually interact with humans. But I would argue that, in fact, it's probably the tech companies that are experimenting the most with, how do we get our team to interact and all that. And if you want to help people or help animals, yes, you can become a doctor and help, individuals. But, think about how you can help people with technology. You can have a much bigger influence on the world and helping people through technology.
Dr. Lin, there's a lot of questions about the difference between computer science and electrical engineering. Can you tell students a little bit about that, please?
Sure. So first of all, I think there are two questions. One is computer science versus electrical engineering, but a more confusing one is computer science versus electrical and computer engineering, which at UT, ECE is one department. So electrical engineering is a little more clearly distinguished because it's talking about, devices and circuits and really low-level things about how you actually build, I guess, physical hardware, right? But the one that's more confusing is computer engineering versus computer science. And I think that in many ways, these are actually synonyms, right? Some people have this notion that computer engineering, it involves the hardware aspects, whereas computer science involves the software aspects. And that might be true at some places. For example, at some schools, they actually do that. But at UT, you should, if you're considering UT, you should really think about ECE and CS as sort of very similar departments, right? And the way to understand this is that computer science has roots in both math and engineering, right? And so it turns out that our department is in the College of Natural Sciences, because that's where math is, and ECE is in the engineering department because that's where all of engineering is, right? And so we at UT have these two departments that have grown. And so, for example, I do research in computer architecture, which is how do we build hardware so that it's efficient and fast and uses low power and all that kind of stuff. We, of course, have folks who do software engineering and robotics and operating systems and graphics and all sorts of theory of CS and all that kind of stuff. But if you go to ECE, they do the same thing. They have computer architects, they have software engineers, they have machine learning folks. So really, it's two very similar departments in terms of scope, okay? So now I guess you might ask, well, wait a minute, if I want to apply to UT, where should I go? And there, what I would suggest is that you look at the two departments and decide which of the two you think is better. I think I know the answer, but you should find out for yourself. And there are differences stylistically in terms of how they treat students and everything like that. We're broader, I think, in terms of computing, whereas they're broader in terms of extending into EE, electrical engineering.
Thank you. Dr. Lin, we have a very prestigious and highly sought after program called the Turing Scholars Program, which you have been the director of. Can you tell students a little bit about the program and kind of some ways they could be competitive for it?
Sure. So I guess the way to think about Turing Scholars is it's an honors program for computer science majors. And the goal is to really challenge our very best and most motivated students. And so it's very small. We typically matriculate about 50 freshmen into the program every year. This next year, I think we're only going to be about 38 or so. It's very small this year. And because of its size, we are able to give these students all sorts of really interesting opportunities, right? So for example, there's a set of honors courses that they take, and they also do undergraduate research culminating in an honors thesis. On top of this, it's a very, very small, tight-knit community. So they're very supportive of each other. They get lots of contact with faculty and so forth. And, you know, we kind of put all these amazing students there and stir the pot, and they do amazing things, right? So, I don't know, we've had freshmen doing amazing research. We've had students start companies and all sorts of things, right? So I guess the way to look at it is, if you want to be one of the best, if you want to be one of the leaders of tomorrow, then, you know, in the past, you might have to go to some other fancy private school that pay a lot of money. But for the last 15, 20 years now, you can instead go to Turing Scholars. If you come to the Turing Scholars program and are successful, you can be as successful as anybody anywhere in the world. Okay, now how do students get in? So typically students apply as part of their UT application. It's not a lot of extra work. There is, you know, another essay or two and the required letter and so forth. I guess what I would say is that, number one, if you're not sure whether you're, you know, qualified, just apply, right? The cost is not that high. And I think that right now, the applicant pool is very self-selective. And I think we're missing students who are actually really strong, but go, well, you know, I'm not, you know, they just don't know if they're good enough. But I think you should just let us decide, and you should apply. So that's number one. Number two, what are we looking for? So we do a holistic review. In fact, in many ways, our admissions process is very much like what you might find at, I don't know, Stanford or Princeton. It's a holistic review. We are looking for students that really stand out in some way, right? And it can be a variety of ways. And it's hard to say what that is because for every student, it's different, right? But generally speaking, we're looking for students who have shown an interest in science, in math, in computer science, and who have indicated that they're highly motivated. You know, they're not spending all their time, you know, in the library or in the room just studying, although they might do some of that, but they're doing other great things. And some of those things, I mean, you know, last year we admitted somebody who was a world-class triathlete, right? Why do we care, right? Because number one, as I said earlier, computer science is so outward-looking, you never know what you're going to apply computing to that's going to change the world, okay? And secondly, we're looking for people, like I said, who are outstanding. And if you can, you know, get great grades and do all sorts of great things while you're a world-class athlete, well, that probably means you're pretty outstanding, right? So my advice would be, if you're interested, apply. And if you're trying to play the game as to what we're looking for, don't play that game. Do what you are passionate about, find out what you're passionate about, because of the nature of computer science, that might be the thing that gets you in, okay? We're looking for just really interesting, smart, motivated people.
Dr. Lin, do you want to talk a little bit about our computer science business program?
Sure. Sort of based on the heels of the success of our Turing Scholars program, we last year instituted a new honors program that is joint with the Macomb School of Business, and it's called imaginatively Computer Science Business Honors. And the way to think about this is we've sort of taken, at a first approximation, two really great honors programs, Business Honors and Turing Scholars, and we fuse them together, right? And this is Computer Science Business Honors. And so the students who join this program are effectively double majors in business and computer science. And we have currently created a curriculum that can be completed in 4 years. And so it's a little bit slim on, say, you know, the computer, like if you compare it to, say, the Turing Scholars program, the curriculum is a little bit thinner in terms of computer science, right? And it's also been slimmed down a little bit on the business side in terms of some of the electives and some of the flexibility you might have. But we did that so we could fit in 4 years. And we also believe that, you know, our honor students are going to be so high achieving that many of them will come in with lots of college credit through AP and other things, that they will actually recoup a lot of that flexibility and still have chances to take, you know, more business or more CS courses or more electives as they wish. So anyways, if you look at business, a lot of companies are realizing that what they need are not just business students, but business students that have some kind of technical background. Might be in engineering, might be in math, or might be in computer science. And so really CSB is a response to this. There's overwhelming demand for these types of students out in the workforce.
Dr. Lin, can you talk a little bit about what makes students successful in the field of computer science?
Very good question. And I'm glad you asked, because I think there are, in fact, many of you students know, have met students where, you know, there's some loudmouth who seems to know everything about computers, and maybe they've been programming or taking apart computers since they were little toddlers, right? And so you're intimidated. And my message for you is don't be intimidated. And in fact, interestingly, I have found that a lot of times these loudmouths don't actually do that well in my classes. So to answer your question, I think that the number one quality is persistence, right? And so if you have a passion, if you feel like you want to succeed, and you are willing to sort of show your grit, then I'm very confident that you will succeed. And in particular, you don't need to have come into computer science in college having taken many, many courses, right? When I was, of course, it's a different day back then, but when I went to college, I had taken just a little bit of programming in high school, just a few weeks, and to the point where I thought I didn't really understand it, and it was really, I actually didn't like it, right? You probably have had more, but don't worry, because we can teach you what you need to learn when you get here, right? So persistence, and if you have an interest, then just go for it.
And Calvin, I have one other question. What classes do you teach?
I teach in the honors program, an honors data structures course. I teach I also teach in the honors program a 1-credit course called Intro to Computer Science Research. And it's all about sort of why you might want to do an honors thesis or undergraduate research, how you get involved, and that kind of stuff. And I also teach typically a graduate course, and I've taught a variety of different graduate courses, some in parallel computing, some in compilers. Most recently, I've mainly been teaching graduate courses in computer architecture. But one thing I will point out is that every year in this graduate course, I've had a number of undergraduate students as well, and they've done very, very well. In fact, I've had a bunch of freshman Turing Scholars taking my graduate computer architecture course, and they've done phenomenally well.
Thank you so much for spending some time with us and sharing your thoughts about the department and things that the students can do to further their knowledge about computer science. Any closing remarks from either of y'all? I
would just say that computer science is an amazing field. So if you're interested, dive in. And UT is an awesome place to study it, and for reasons I didn't get into, which is, we have a great culture and environment and all that kind of thing.